Hello and welcome to Mr. Walton's physics lessons. In today's lesson we'll be looking at Newton's second law. This is from the forces topic of GCSE combined science and triple physics. By the end of the lesson you should be able to describe Newton's second law, and use the formula, force equals mass times acceleration. In the previous lesson we looked at Newton's first law of motion. It can be stated as, an object will remain at rest, or in uniform motion in a straight line, unless acted upon by an unbalanced force. This tells us that if a resultant force acts on an object, the object can start moving, stop moving, speed up, slow down, or even change direction. Newton's second law of motion states, the acceleration of an object is proportional to the resultant force on the object, and inversely proportional to its mass. This can be written as a formula, force equals mass times acceleration, or F equals ma. So what does this mean? Let's take a look at the first part of the law. The acceleration of an object is proportional to the resultant force acting on the object. If James pushes his van with enough force, he can make it move, or accelerate. If he pushes with more force, he can make it move faster. In other words, give it a larger acceleration. This can be shown using the formula, force equals mass times acceleration, or F equals ma. In the first diagram, James pushes with a certain amount of force. This causes the van to accelerate. In the second diagram, James uses a greater force, and so the van must have a greater acceleration. So, for an object with constant mass, the acceleration of the object is proportional to the force applied to it. The second part of the law says, the acceleration of the object is inversely proportional to the mass of the object. Let's have a look at what this means. If Jack pushes the empty chair, it will move fairly easily. So Jack's push force causes quite a large acceleration. But if Jane sits on the chair, it's more difficult to move, because of the larger mass. So, if Jack pushes with the same force, the acceleration of the chair will be smaller. So, using F equals ma. If the mass of an object is increased, the acceleration will decrease for any given force. And if the mass is reduced, the acceleration will increase. It is important that you understand how to use the formula, F equals ma. Let's try a few example questions. Question 1. Calculate the force needed to accelerate a car with a mass of 900 kilograms, at 2.5 meters per second squared. As with all calculation questions, you need to write the formula first, F equals ma. Then, you substitute the numbers from the question into the formula, so F equals 900 times 2.5. This gives a force of 2,250 newtons. Question 2. Calculate the acceleration of a 26 kilogram shopping trolley pushed with a resultant force of 12 newtons. In this example you need to rearrange the formula to calculate the acceleration. So the formula becomes acceleration equals force divided by mass, or equals F divided by m. So 26 divided by 12 gives an acceleration of 2.2 meters per second squared. Question 3. Calculate the mass of a skater who accelerates at 3 meters per second squared when pushing off a wall with a force of 144 newtons. This time you need to rearrange the formula to calculate the mass. So the formula becomes mass equals force divided by acceleration, or m equals F divided by a. So 144 divided by 3 gives a mass of 48 kilograms. So you should now be able to describe Newton's second law of motion and use the formula F equals ma to calculate the force, mass, and acceleration of objects. Thank you for watching. See you in the next lesson.